All right, hello everyone, and welcome back to Math with Miss Lastly. Ooh, that's a mouthful. Anyways, today we are on day 3 of our graphing trig functions unit, which is the phase shift day. All right, so what we're going to do today is we're going to kind of talk about what is a phase shift. Looking at our transformation equation, what part of it is it? Then we're going to figure out how we figure out what the phase shift is, and then we're going to do a couple practice problems. All right, I will say that out of the 4 different transformations, this is probably the one that's the most challenging, only because it's moving your x-axis, and this does sometimes cause people to have a little bit of a hard time figuring out their x-axis values. All right, so we kind of saved the toughest one, I guess, for last. All right, but it's not that bad. It's not that bad, I promise. All right, I will show you exactly step by step what you should do every time, and if you follow those steps, you cannot get this one wrong. All right, here we go. Okay, so first off, we have our transformation equation right here. All right, we've talked about what A is. That's our amplitude. All right, the B value is our frequency, which is how we can figure out the periods for each of our different equations. The D value we've talked about, that's our vertical shift, or it creates our midline equation, the middle kind of our graph. So really the only thing we haven't talked about yet is the C value. And this is our phase shift. All right, so this is, ooh, go away. All right, so right here, this is where we get our phase shift. Now, I know that we've seen this, C value in other functions, and we didn't call it this. Normally, this is called a horizontal translation. It moves our graph left to right. And in this equation, it also moves our graph from left to right. So it's doing the exact same thing. The problem is, if you think about our x-axis shifting left and right, you're moving degrees, right? So it's not as simple as just moving to the left 2 on the x-axis, because now moving to the left 2 messes up our period and just the whole graph is kind of thrown off, which is what makes this a little bit more complicated than a normal horizontal translation. All right, so our phase shift, we'll just write it down. So defining what it is. So our phase shift is the horizontal translation, or shift left or right along the x-axis. All right, more simply put, it moves our graph left or right. What? Right. It's taking a bit to catch up on my writing. Okay, so we're moving our x-axis values. All right, now, one important thing that we talked about in our last video, but I just want to re-talk about it. All right, when you're looking at the problem, so normally when you're given one of these equations, just like on your last homework, we notice that the B value is not usually started, like it's not pulled out at first, right? So just looking at an example here, we're not actually going to do this one. I'm just 100% making this up. All right, so if we had like y equals sine of 4x plus 100 degrees, right? So if we had something like this, what a lot of people like to do is they'll look at it and they'll say, okay, this is my phase shift. They'll say they'll plus 100. So we know that just, based on what we've learned before, and I'll write this down, right? So if you have a minus a C value, so minus C, that actually moves to the right. This moves right. A plus C value moves left. just a reminder, that's the same in all of our other functions that we've dealt with. That same rule applies, right? Remember, horizontal transformations always kind of do the opposite of what you think they're going to do. So the minus moves to the positive direction, the plus moves left. Anyways, with this example, a lot of times what people will say is that we have a shift, they'll say left 100 degrees. That is wrong. That is 100% incorrect. All right. In order to get the appropriate phase shift, you have to pull the B value out first. All right. We are not shifting our graph by 100. We're shifting our graph by 4 times something equals 100. All right. So you have to pull the B value out first. All right. So this is wrong. We don't want to do that. All right. What we have to do is first rewrite it so that the B value, that 4, is kind of factored out. So we would say like sine, so we're going to pull the 4 out. And this is where we have that greatest common factor, right? When we GCF, or we pull something out front. So we have to divide each piece here by 4. So 4x divided by 4 is x, plus 100 divided by 4 is 25 degrees. Remember, we should be able to distribute the 4 back in and get back to what we originally had. All right, so if you look back and like double check, and that second number, if we multiply it by the B value doesn't equal what you started with, then you've done something wrong. All right, but now this is correct. And so we can see our actual phase shift is left 25 degrees. That is correct. All right, so always have to, we'll put a little star, always pull the B value out first. All right, so like I said, last video we talked about that B value, which is next to the X. So before you can actually find your phase shift, you have to divide out by that B value so that it's pulled out to the front. We kind of did this when we were doing other transformations. More of it was already done for you, right? So when we were doing, say, like a quadratic equation, right? We would see something like this. So like, I don't know, x plus 3 over 2 squared. But the whole thing was over 2, right? Or we would see 3x plus 2 squared, right? Something like this, all right? But you were given it this way, all right? Now when we're doing the problems, they're not going to give it to us with the B value out front, so we have to remember to always pull the B value out first before we can figure out our phase shift. Okay, so let's get into it. Let's just do these 2 example problems. Okay. So first things first, like I said, before we can actually do the problem, we need to make sure that we rewrite it with the B value pulled out front. All right, not front of the whole thing, but like in the parentheses, we have to factor that out. All right, so for this first one, I'm going to rewrite it. Everything's going to stay the same, except I'm going to pull my B value out front. This is 2 sine parentheses. Now the B value is whatever is attached to the X. So I'm pulling out that thing attached to the X. In this case, it's 1/3 parentheses X. Now I divided X by 1/3. That's how I was able to pull it out front. So we need to do the same thing with 120. So we're going to take 120 and divide it by 1/3, which is actually going to multiply 120 by 3. All right. So if you take your calculator, you type in 120 divided by parentheses 1 divided by 3. All right, so I know you probably can't see that very well, but that's what we're doing, right? 120 divided by parentheses 1/3. Hit enter, and that's going to give us 360. So this is really plus 360. Just remember, when you're dividing by a fraction, and then plus 5. I ran out of space right there. Remember, when you divide by a fraction, it actually like multiplies it, right? So just be careful with that one. All right, so now we have it written in the correct transformation equation that we wanted. All right, so now we're going to go ahead and we're going to pull out our A, B, C, and D values. All right, so A, that's the number out front. That's 2. All right, B, that's that 1/3 that we pulled out. All right, C, that's the 360, not 120. So that's 360. All right, and some people like to put what direction. So like since it's plus 360, I know that this means it's 360 to the left. All right, but you don't have to. If you just know that, when you graph, I'll know what you meant. All right, and then last but not least is our D value. Boop, boop, boop. And that is up 5, or you can say 5 and then add up, right? Plus 5 means we're going up 5. Okay, so those are all of our different A values. All right, so now we need to figure out our period. So from our last video, hopefully you remember how to find period. If not, we'll go through it again. All right, the period is 360 or 2 pi, but we're in degrees right now. So 360 divided by the B value. So it's 360 divided by the B value, which is 1/3. All right, again, that's when you divide by a fraction, it kind of is gonna, right, we flip and multiply. So this is gonna be 360 divided by parentheses 1/3, which is 1080, so 1080. All right, so that's our period. So we only do one sine graph every 1080 degrees. All right, so that's kind of a fat graph, right? All right, midline, that is our up 5, so that's going to be y equals 5. All right, and then our range, right, that's the difference, right? So we take our midline, we add the amplitude, and we take the midline, we subtract the amplitude to get our range. All right, so if our midline is 5, to get our smallest value, we subtract 2. So 5 minus 2 gives us 3. And then to get our max value, it's going to be the midline plus the amplitude. So 5 plus 2, which gives us 7. Okay, so those are all the key pieces. So now I can go ahead and start looking at my graph. All right. Let's actually set this page up a little bit different because it's hard to see what we got going on here. I just dropped something. What was it? So nothing important. Okay, so what I'm gonna do, I still want to do both examples, but I think I'm gonna put them side by side instead of, yeah, just delete that for right now. All right, hold on. Okay, there we go. I just moved it around. So that'll be a little bit easier for us to be able to see all the information because it's right next to it. Okay, so here we go. All right, going to our graph. Let's start by labeling our y-axis. Okay, so I like to, again, you know, everyone does their own thing, but I like to use the middle line as my midline. So just as long as we make sure we label everything, then it's everything, then it'll be okay. All right, so this is my midline, so I'll say 5. All right, right here. And then I have my max value of 7, and then I have my minimum value of 2. Just make sure you space it evenly, like I kind of have going on here. All right, that's the important part. Next, we're going to go ahead and we're going to label our x-axis. Now, this is where it's going to get a little strange. All right, so our starting point is going to be wherever our phase shift was. All right, so our first point, usually we're at 0, right? Usually we start at 0, whether it's sine or cosine, our x value is 0, all right? So we're taking that 0 point and we're moving it by our phase shift. And this is telling us we're going to go left 360 degrees. So again, I know that I have my y-axis kind of all the way on the left-hand side. This would be more appropriate, right, if I were to kind of do this in the negative direction, but I'm not going to do that. I'm just going to make sure I really clearly label this x-axis. So right here, my first point, this is going to be negative 360 degrees. That's my starting point. All right. Now, just like with my other graphs, I have a total of 5 points. All right, so I'm going to list out all my points. All right, and just like we did when we were doing our change of our period, we're going to take our starting point, which used to be 0, but now it's negative 360. We're going to add the period to that because we know that we're going to finish after one period, which in this case is 1080 or 1080 degrees. So I'm going to take my calculator. I'm going to negative 360 plus 1080, and that's my ending point. That's going to be positive 720. So I know that's where I'm going to end. All right, here, let me move my little right up there. Okay, all right, so I know that's my ending point. So now I need to find my other 3 values. And again, we talked about this in our last video. There are 2 techniques. You can use that midpoint technique where you add the ends, divide by 2 to get what's in between. Or you can take your period and divide it by 4 and then add that number each time. And I like that method. So I'm going to take 1080, which is my period. I'm going to divide it by 4, and that's 270. All right, so that means each time I move, I have to add 270 degrees. So each time I move, I'm going to add 270, add 270. Add 270, and I should end up at 720. All right, so let's do that. So negative 360 plus 270, that gives me negative 90 plus 270, positive 180 plus 270, 450, and then just to double check, plus 270, enter, 720, I got it. Okay, so those are my x-axis values. All right, now from here, you just look to see if it's sine or cosine, and you'll know where to put your first point. So this is a sine graph. All right, so with sine, my first point is at 0, all right, or my midline, okay, and it's positive 2, so that means I'm going to start by going up to my max. All right, so this is my new 0, so at negative 360, that's my new 0. Now I'm going to go up to 7, back down to my midline, down to my min, which is 2, and then back up to my midline. There's my sine shape, all right, and then I connect my dots, and there's my sine graph. Now you can also do a little extra, right, because we know that it does keep going in both directions. So if you like to put the arrow on the end, go ahead and put the arrow on the end. Right? Because we know that's the most accurate, right? We know it's going to go up like that. There we go. That's better. It almost looks the same. It doesn't actually matter. Okay, but there's one period of our sine graph. So remember, from here to here, that's our period of 1080. All right, and then our starting point, that's our phase shift. Phase shift, right? Left 360, right? In the negative direction. All right, and then we have our amplitude of 2, right, in both directions. Amplitude of 2, oh, which means this should be 3. Oh my goodness, why did I put 2? I didn't subtract right. This should be 3. If you caught that before me, then good job. And then, yeah, the 5, right, so this is my midline, right, that's my D value. So those are all of our transformations, all right? So we have our period, we have our phase shift, which causes our graph to start at negative 360 instead of 0. We have the amplitude that is making us go up to and down to from that middle line, and we're not having that middle line at 0, we have it at positive 5 because that's our midline, our vertical shift. So we have all 4 transformations in this one graph. Okay, we're going to do one more example with a cosine function, and then that'll be it for our video for today. All right, and this is also in radians, so you can see how this all works in radians. Okay, so first things first, just like with the last one, we need to rewrite it so that the b value is kind of factored out of that parentheses. All right, so we're gonna rewrite this. We have -3 cosine parentheses. Now our b value is whatever is connected to the x. In this case, it's 2 parentheses. So now we're dividing everything by 2. This becomes x plus, all right, now I know fractions are tough, so we can go to the calculator, type in 2/3. Don't hit the pi button. If you hit pi, then it's going to give you this irrational decimal. We don't want that. So 2/3 divided by 2, all right, and then hit math, enter, enter. You could obviously do this by hand, but if you have a calculator, it does make life a lot simpler. All right, so if I take 2/3 and I divide it by 2, that gives me 1/3. So I'm left with pi over 3. And then that -1 on the outside. Here, let me move my, there we go. Boop. Okay, so there we are. All right, so there's our b value pulled out. Okay, so now we're going to go through it just like we did before. So our a value, all right, is going to be 3. All right, so it's 3. All right, now it is -3, all right? That doesn't affect my amplitude, right? I'm still gonna go up 3 from the midline and down 3 from the midline, but the negative does change if I start my graph going up or if I start my graph going down, right? The negative means we kind of reflect it upside down. All right, so we'll deal with that at the end. So, but if you want to put -3, a lot of people do just to remind themselves for their amplitude that it is a negative reflection. You could put -3, I wouldn't mark it wrong. But technically amplitude is always going to be positive. Okay, next up is our b value, which we've pulled out. That's our 2. All right, then we have our c value, which is pi over 3. So pi over 3. All right, and then last but not least is our d value, which is -1. Okay, now, again, just like before with the plus pi over 3, you could say this is left pi over 3. And the -1, right, we're going down 1. If that helps, you could write that. It's not necessary though. Okay, so for our period, we take our, so we're in radians, so we're going to do 2 pi. And we're going to divide that by the b value, which is 2. So our period is pi. All right, our midline is y equals -1. And then our range, all right, so remember that's our midline. So it's the midline plus the amplitude, and then midline minus the amplitude, right? That's how we get our range. So for our smallest value, we take -1 and we subtract 3. So -1 minus 3 is -4. And then our max, right, we take our midline and we add 3. So -1 plus 3 is 2. All right, so that's our range. So -4 to +2. So now I can go ahead and start setting up my y-axis. So I'm going to put my midline right here in the center. So that's my -1. All right, I'm going, my max is 2, my min is -4. Did it right this time. Okay, and now we need to start setting up our x-axis. So we have 1, 2, 3, 4, 5 points. Okay, now our first point is whatever our phase shift is. So we went left pi over 3. So our first point is going to be -pi over 3. All right, our last point is just add the period, right? So to get to our last point, add the period, which is pi. Okay, so -1/3 plus pi, And again, you could use your calculator if you want to, but this one's kind of not too bad to do by hand, right? So pi in thirds would be 3 over 3. So we have negative 1/3 plus 3 over 3, so that's going to be positive 2/3. So this is going to be 2 pi over 3. All right. So we added our period of pi. That gave us our last point. All right, now what we need to do is take our, so what I do is take the period divided by 4 and add that each time. So my period is pi divided by 4. Oops, there we go. So I'm going to add pi over 4 each time. Bloop, plus pi over 4, plus pi over 4, and plus pi over 4. Okay, so handy dandy calculator, I type in negative 1/3 plus 1/4, math, enter, enter. That's negative pi over 12. All right, plus 1/4. This gives me positive pi over 6 plus 1/4, 5 pi over 12. All right, and then plus 1/4 again, and I should get 2 over 3, and I do. Bam! So I set up my x-axis correctly. Good stuff. Now I need to go through and I just need to plot my points. All right, so since this is cosine, cosine usually starts at our max value, right? Up 1, in this case, right, 2, but since it's negative, I know that it's going to be reflected upside down. So since we have that minus 3 out front, I'm actually going to start at my minimum value, which is negative 4. And then I'm going to go to 0, and then up to my max, and then back to 0, and then down to the minimum again. And then I'm going to connect my dots. And I'll leave a little space on the ends to do my arrows. All right, and there's my cosine graph. So I hope that was helpful. I know that this was a lot. That's why we did 2 examples. Make sure that you are practicing this and you really make sure you do the homework for this stuff, because this is, like I said, this is the hardest one, but now that's it. That's all the transformations that we have to deal with. All right, so hopefully that helps, and I will see you guys in class. Bye.